EV battery gigafactories are among the largest manufacturing facilities in the world. These massive plants produce the energy that powers electric vehicles. Inside these facilities, thousands of machines operate continuously. Automation drives nearly every step of battery production. Battery production begins with carefully prepared raw materials. Lithium, nickel, and other elements form the foundation of energy storage. These materials are mixed to create battery electrode compounds. Precision mixing determines battery performance and lifespan. The mixed material is coated onto thin metal sheets to form electrodes. This step is critical for battery efficiency. Coated electrode sheets move through long drying ovens. Controlled heat removes moisture and stabilizes the material. Endless electrode sheets traveling through heated tunnel oven, warm glow inside chamber. After drying, electrodes are compressed to improve density. High-pressure rollers enhance battery performance. The processed sheets are cut into precise shapes. Accuracy ensures consistent battery cell assembly. Electrode layers are stacked or rolled to form battery cells. This stage defines the internal structure of each cell. The layered materials are sealed inside protective casings. Cells are prepared for electrolyte filling. Electrolyte is injected into each cell to enable energy movement. This liquid allows ions to flow between electrodes. Filled cells are sealed to prevent leakage and contamination. Perfect sealing ensures long-term battery safety. Newly assembled cells undergo formation cycling for the first time. Charging and discharging activates internal chemistry. Formation is followed by aging and stabilization periods. Cells rest while performance characteristics are monitored. Cells are inspected using advanced quality control systems. Defective units are removed automatically. Approved battery cells move toward module assembly lines. Hundreds of cells are grouped into structured units. Rows of identical battery cells traveling on conveyor into assembly zone. Robotic arms preparing grouping layout. Robotic systems position cells with extreme precision. Alignment is critical for electrical performance and safety. Electrical connections link cells inside each module. Conductive pathways allow energy to flow efficiently. Robotic welding creates tiny connection points between cells in a clean environment. Cooling systems are integrated to manage battery temperature. Thermal control protects performance and lifespan. Completed modules move forward for pack assembly. Larger battery structures begin taking shape. Multiple modules are installed into large battery pack frames. The pack structure forms the backbone of electric vehicles. High-voltage wiring connects modules inside the battery pack. Complex electrical systems enable power distribution. Battery management systems are installed to monitor performance. Electronics track temperature, voltage, and safety conditions. Protective casings seal the battery pack for structural safety. Enclosures protect internal components from external conditions. Completed battery packs undergo initial functional testing. Systems verify electrical integrity before approval. Battery packs are charged and discharged to validate performance. Controlled testing confirms reliability under real conditions. Thermal testing evaluates how batteries respond to temperature changes. Safety systems are verified under extreme scenarios. Vibration and durability tests simulate real vehicle movement. Mechanical stress testing ensures long-term stability. Approved battery packs move toward vehicle integration.
Gigafactory production supports the growing electric vehicle industry.
Automated logistics systems transport battery packs across the facility. Autonomous vehicles move heavy components safely and efficiently. Battery packs are prepared for shipment to vehicle assembly plants. Protective packaging prevents damage during transport. Gigafactories operate around the clock to meet global demand. Continuous production supports the rapid growth of electric vehicles. Thousands of sensors monitor equipment performance in real time. Data-driven manufacturing improves efficiency and reliability. Cleanroom environments maintain strict air quality standards. Controlled conditions prevent reworkers and robots move slowly in a bright, sterile environment, as air filtration systems maintain precision. Precision manufacturing ensures consistent battery cell performance. Even minor variations are carefully controlled. Software coordinates machines across the entire production line. Central systems manage timing and material flow automatically. Engineers continuously optimize battery chemistry for higher energy density. Gigafactories are scaling rapidly to meet global EV demand. New facilities are being built across multiple continents. Supply chains deliver raw materials from around the world. Global logistics support continuous battery production. Recycling systems recover valuable materials from used batteries. Circular process reduces unused packs, separating components on conveyors. This is a sustainability transition. Recovered materials return to the production cycle again. Battery manufacturing increasingly follows circular economy principles. Energy consumption inside gigafactories is carefully optimized. Efficient systems reduce environmental impact during production. Renewable energy increasingly powers battery manufacturing facilities. Clean energy supports sustainable electric mobility. Water management systems support cooling and manufacturing processes. Closed-loop system, industrial water treatment system inside gigafactory, pipes and filtration tanks visible, slow cinematic engineering reveal. Safety protocols protect workers and equipment at every stage. Strict procedures reduce operational risks. Fast charging capability is a major development focus. Engineers work to reduce charging time significantly. Thermal management improvements prevent overheating during rapid charging. Cooling innovation enhances battery reliability. Thermal imaging reveals the heat distribution, showcasing engineering precision. Manufacturers explore alternative chemistries to reduce rare material dependence. New formulas aim for affordability and sustainability. Battery lifespan testing simulates years of usage in controlled conditions. Long-term durability remains a key priority. Machine learning models predict battery behavior under different conditions. AI supports faster development cycles. Gigafactories represent a shift toward electrified transportation infrastructure. Battery production underpins the EV revolution. As production scales, battery costs continue to decrease globally. Manufacturing efficiency drives affordability. Lower costs accelerate electric vehicle adoption worldwide. Battery manufacturing plays a central role in energy transition. Gigafactories create thousands of jobs across engineering and manufacturing. Workforce expansion supports rapid industry growth. Regional gigafactories strengthen local supply chains. Manufacturing closer to vehicle assembly improves efficiency. Governments invest heavily in battery manufacturing infrastructure. Policy incentives accelerate facility expansion worldwide. Gigafactory construction sites rise, symbolizing the global push for electric vehicle dominance. Strategic partnerships between automakers and battery companies drive innovation. Continuous improvement remains central to gigafactory operations. Manufacturing evolves with each production cycle. Gigafactories continue scaling production capacity each year. Expansion enables faster global electric vehicle adoption.
Massive Gigafactory phase sincerity.
Advanced automation reduces manufacturing errors significantly. Precision robotics maintain consistent product quality. Standardized battery designs simplify large-scale manufacturing. Modular architecture improves efficiency and flexibility. Supply chain optimization ensures uninterrupted production flow. Logistics planning coordinates materials across continents. Cargo containers moving through port into trucks then factory. Gigafactories represent one of the most complex manufacturing systems ever built. Battery production integrates chemistry, engineering, and automation. Battery manufacturing continues evolving as new technologies emerge. Each generation improves performance and efficiency. Automation allows gigafactories to scale production rapidly. High-speed lines support global electric vehicle demand. Data analytics help identify inefficiencies across production lines. Continuous monitoring improves manufacturing output. Sustainability remains central to future battery manufacturing strategies. Facilities aim to reduce emissions and resource use. The next generation of gigafactories will be smarter and more autonomous. Intelligent systems will manage entire production ecosystems. Battery research continues pushing the limits of energy storage technology. Scientists explore new materials to unlock higher performance. Improved recycling methods recover valuable materials from used batteries. Circular manufacturing reduces environmental impact. Battery manufacturing plays a critical role in the global energy transition. Electrification depends on scalable production. Gigafactories symbolize the shift toward a cleaner transportation future. Large-scale battery production powers sustainable mobility. Continuous innovation ensures battery technology keeps improving each year. Manufacturing advances drive better performance and lower costs. Engineers design batteries to be safer under extreme conditions. Safety systems are integrated into every layer of the pack. Standardization allows manufacturers to scale production globally. Consistent designs simplify assembly and maintenance. Gigafactories represent a foundation of modern electrified infrastructure. Battery manufacturing supports to urban hubs. These facilities drive change. This is the global impact of sustainable mobility. Future battery technologies aim to deliver longer range and faster charging. Research continues redefining energy storage possibilities. Automation will continue shaping the evolution of gigafactories. Intelligent systems will manage complex production ecosystems. Battery manufacturing stands at the center of the electric vehicle revolution. Gigafactories enable the transition towards sustainable transport. The future of transportation depends on how batteries are made today. Gigafactories transform energy into mobility for the world.